Systematic way of categorization of point group we have discussed. But in order to make it simple, let me explain that in other way. I consider a few molecules. I write their possible symmetry operations. And then I give one logic. We have to apply that logic to find point group. Majority of the molecules come in that category, therefore I am discussing. Here all point groups I am not discussing. The first molecule I want to consider is H2. See the all possible operations for the H2. Next I want to consider HCl molecule. See the operations possible for HCl molecule. Then let us consider H2O molecule. See the operations possible for H2O molecule. Then NH3 molecule. See the possible operations for NH3 molecule. Then BCl3 molecule. See the operations possible for BCl3 molecule. And last, trans-dichloroethylene. See the operations possible. How many total operations are there in hydrogen molecule? Infinite number of operations. So H means order of the point group is infinity. How many are the possible operations for HCl molecule? Infinite number of possible operations. So H is equal to infinity. For water molecule, H is equal to 4. For ammonia molecule, H is equal to 6. For BCl3 molecule, H is equal to 12. And for trans-dichloroethylene, H is equal to 4. So total operations we are getting. So first two molecules are there where order of the operation is infinity. Therefore we say high ordered symmetry possessing molecules H2 and HCl. Now listen carefully the logic. If we consider Cn as a principal axis where n is the order of the principal axis. If the order of principal axis is equal to number of subsidiary C2 axes, means n C2 if they are there, then point group will be of category capital D, dihedral symmetry. If not, capital C. Let us apply this logic. H2 molecule. Order of principal axis infinity. Number of subsidiary axis infinity. Yes. So which symbol should be there? Capital D. Then consider HCl molecule. Order of principal axis infinity. Number of subsidiary axis C2 axis not there. Then which symbol? Capital C. Then consider H2O molecule. Principal axis C2. Number of subsidiary axis. No. Then which symbol? Capital C. Ammonia molecule. Principal axis C3. 3 is the order. Number of subsidiary axis not there. So symbol capital C. Then consider BCl3 molecule. Principal axis C3. Order of principal axis 3. Are there subsidiary C2 axis? Yes. How many? 3. So order of principal axis is equal to number of subsidiary axis. Then which symbol? Capital D. Now last example. Trans-dichloroethylene. Principal axis C2. Are there any subsidiary axis? No. So which symbol? Capital C. So one step we achieved to label the point group. Now second step, followed by this letter C or capital D, we need to write order of the principal axis as a suffix. For first molecule, hydrogen molecule, order of principal axis infinity. So I need to write D infinity. HCl molecule, order of principal axis infinity. So what is present there? C infinity. H2O molecule, order of principal axis 2. So I wrote there C2. NH3 molecule, order of principal axis 3. So representation C3. BCl3 molecule, order of principal axis 3. So representation D3. Trans-dichloroethylene, order of principal axis 2. So representation C2. Next step is a label of plane of symmetry. 3 planes are there. Which are those? Vertical, dihedral and horizontal. Among these, superior plane is a horizontal plane. Even if others are existing, we have to represent that horizontal plane. If horizontal plane is absent, if say dihedral and vertical planes are there, then we have to represent dihedral plane. If horizontal planes are not there, dihedral planes are not there, only vertical planes are there, then vertical plane. So what is our superiority of the representation or hierarchy of representation? Horizontal plane, first priority, second dihedral plane, and third vertical plane. Which are the examples that I considered? The dihedral plane is not there. We will apply this for horizontal and vertical plane. In case of H2 molecule, both kinds of planes are there, horizontal and vertical. To whom will we give priority? Yes, horizontal plane. So what is the representation? D infinity H. That's a point group for H2 molecule. HCl molecule. Which planes are there? Only vertical planes are there. So representation C infinity V. That's a point group of HCl molecule. Now next, water molecule. Only vertical planes are there. So its point group C2V. Ammonia molecule, only vertical planes are there. So representation C3V, BCl3 molecule, where both horizontal and vertical kinds of planes are there. So to whom shall we give priority? Right, horizontal plane. Therefore, point group of BCl3 molecule is D3H, last molecule. Trans dichloroethylene. There is only horizontal plane. So representation C2H. Is it clear? Now I give homework. Represent all symmetry operations for chloroform molecule and write its point group using this simple method.
One thing I like to make a clear, chances of confusion are there. For HCl molecule, I said there are no C2 excess, but during representation, I represented C2. Actually, whatever the C2 is represented is not separate C2 excess, it is a C infinity axis only. But C2 operation out of the all possible operations of C infinity is separately represented. It is a coincident axis, or this is a coincident operation. Importance is there to represent it separately. It doesn't mean it is a separate subsidiary perpendicular C2 axis to the principal axis. Similar is the case for hydrogen molecule. In case of hydrogen, this is C2 from C infinity can be represented, and further C2 axes are there. Infinite number of C2 axes are there. Those are separately represented. Whichever point groups I discussed here, separately each point group is discussed. Separate videos are prepared. Further examples also are given. Here my interest was only to make a clear how to assign, how to label point group in somewhat simple way.